In this video, I have another example in which we want to use the laws of logarithm and other common logarithms to solve a problem. So let's look at this. In this example, we are given that the logarithm of 2 is equal to m and the logarithm of 3 is equal to n. So we want to find the following in terms of m and or n. So on A we have log 6, on B we've got log 9, on C we have got log 1.5, and on D log of 200. So we want to find all these logarithms on A, B, C and D using the information we have that the logarithm of 2 is equal to m and the logarithm of 3 is equal to n. Alright, so let's straight away get to the solution. Perhaps you'd want to maybe try out this problem before you check out my solution. So I want you to pause the video and start working from now. Alright, so let's start with part A. On A we have the logarithm of 6. Now we want to find the logarithm of 6 in terms of m and or n, and we want to use the information that we have. We've been given the logarithm of 2 and the logarithm of 3 being equal to m and n respectively. Alright, so I want you to see how I'll be working out part A. I can say that the logarithm of 6 is the same as saying the logarithm of 2 times 3, because 6 is 2 times 3. And why have I used this figure specifically is because we know the logarithm of 2 and the logarithm of 3. So that's why I'm using the figures 2 and 3. And using the law of logarithm, this is equal to log 2 plus log 3. Remember our law of logarithm, right, where we're saying that the logarithm of a times b is equal to the logarithm of a plus the logarithm of b. So that is the law of logarithm that I have used. Alright, and now we can get our solution, because the logarithm of 2 here is equal to m. So, and the logarithm of 3 is equal to n. So my solution will simply come out as m plus n. So that's the solution in terms of n, m and n. So that's simply what we'll be doing. That's how we can solve part A. Let's look at part B. On B we have the logarithm of 9. Right, so like we did in example A, you're trying to express 9 in terms of the figures 2 or 3 or both, right? And as I look at 9, I can say that 9 is like 3 squared, right? 9 is 3 squared, and using our law of logarithm, this is 2 log 3. If you remember our law of logarithm, the logarithm of a to the power of x is the same as x times the logarithm of a. So that is the law that I have used right here, right? So when I am here, then I'm almost through, because now the logarithm of 3 I've been given in the question to be n. So my solution will simply come out as 2n. Alright, so maybe you now have an idea of it and you hadn't started working on these ones. So I want you to attempt part C and D and see if you can work them out like I've been doing on A and B. I'll just give you a few minutes to that, so you can pause the video from this moment. Right, let me take you to part C. On C we have the logarithm of 1.5. Now you are asking yourself, how can I express 1.5 in terms of 2 and 3? And we're talking about product quotient relationships here. And if you look at 1.5, you can say that 1.5 is actually 3 over 2. So remember, it has to be a product quotient relationship so that your solution will come out right. Alright, and 1.5 as a fraction is 3 over 2, and according to the law of logarithms, that's logarithm of 3 minus logarithm of 2. logarithm of 3 is n, so we'll be having n minus the logarithm of 2 is m. So in terms of m and n, our solution will come out as n minus m. Alright, lastly, let's go on to d, where we have the logarithm of 200. Right, and for the logarithm of 200, I can say that 200 is equal to the product 2 times 100, which will come out as logarithm of 2 plus the logarithm of 100. Because I know the logarithm of 100, if you remember the common logarithm, so logarithm of 2 is m. The logarithm of 100, we know it's a common logarithm, is 2. So our solution in terms of m will come out as m plus 2. Right, so I hope you've seen how I work out such problems like these ones. They are also common, so I would want you to make sure that you understand how I was doing it, and I'll be giving you more problems to work out so that you can really see if you've really grasped what we were doing in this lesson.